Welcome to First Mile's Climate Heroes. I'm your host, Bruce Bratley, founder of recycling company First Mile. On this show, we meet and learn from the climate heroes who are building solutions right now to tackle climate change. AI is becoming a powerful tool in the fight against climate change. It can help us better understand the impacts of climate change, and it can help us optimize current systems that might not be working as well as they could. And finally, it's accelerating breakthrough new green technologies. This revolution is happening right across clean tech, and waste is no exception. And today's guest is deploying, or I should say guests are deploying AI-powered systems to improve waste sorting and recycling processes to reduce contamination and increase the overall efficiency of recycling. And on this episode, Recycleye are the guests, and I'm excited to talk about AI and the future of waste management. Delfino is a machine learning tech lead at Recycleye, and Zoe Cook is technical sales manager. It's a pleasure to welcome you both to the First Miles Climate Heroes. Welcome to the show.
Thanks for having us.
Well, thank you for having us.
And this is very exciting. I don't very often have two guests on the show, so it's going to be fantastic. So let's start with Benny. Fantastic to have you on the show. How did you get into AI, really? It's such a new thing for lots of us. It's been around a while. And how did you become a climate hero?
Yeah, so I guess my journey into the world of AI has been somewhat unusual. Started with an undergraduate degree in philosophy, actually. So as far away from the maths world of AI as one could be. And I started coding for fun at uni, which then led to a master's in computer science at Imperial. And that's where I met Pete, one of the two co-founders of Recycleye, for the first time. And I wrote my thesis with Recycleye, my master's thesis with Recycleye. And my thesis was specifically on how you can create synthetic data for plastic bottles specifically. So imagine if you want to create data containing transparent bottles, that's really quite hard because transparent bottles just kind of look and reflect the color of the background they're on. And so in trying to solve this problem, I then ended up joining Recycleye and as a computer vision engineer and now tech lead of the machine learning team. But yeah, very exciting.
And there's quite a lot, I mean, philosophy, interesting. There's quite a lot of philosophical questions around what AI might do for society, whether it's good or bad. Is that something you still use in your day job now, or are we sort of immune from worries of the impact of AI when we're just talking about recycling waste, which probably nobody wants to do anyway?
Yeah, no, for sure. A lot of, some of my degree anyways was on ethics, where we started answering questions like that. But a lot of it was more on like logic and the technical sides of that then lead into machine learning. So kind of the first principles of AI, if you will. But yeah, there's definitely lots of really important ethical questions in AI at the moment. A lot of them have kind of caught on a lot when GPT models came out and LLMs have become increasingly popular, and people have really started seeing how powerful AI can be. And, you know, AI has been more and more commercialized. And so as people have been able to use it more, some of these questions became even more important. I think at Recycleye, we definitely have some ethical questions on the use of AI, but I think our use case is slightly easier than some other AI use cases insofar as we really are trying to use tech for the good, for the environment specifically, but definitely tech for good is one of our big mottos, I guess.
Yeah, absolutely. Well, we'll come back to that, and I've got a question around data bias and sorting waste as well. So in your data set, so we'll come back to that. Zoe, welcome to the show. And what's your story of AI? How did you get to Recycleye and become a climate hero? You're both doing incredible things for the planet at Recycleye.
Good, thanks, Bruce. Good to be here. Yeah, I mean, completely different background to Benny. I've really just come from the commercial side. I think I'm one of the very few people at Recycleye that doesn't have an engineering or computer science background. Yeah, so I worked in sales, account management previously, and really wanted to work for a green tech company and in the circular economy, sort of more broadly speaking. The fact that it was AI sort of came second, and really loved what Recycleye was doing. Joined a couple of years ago to start up the sales team with another colleague of mine, and the idea was to kind of, she was an engineer, I have the commercial background, and kind of start up that side of it together.
And I think that's going pretty well. I mean, there's constant, almost weekly news from Recycleye of new robots and AI machines going into factories all over the world now. So obviously having a big impact there.
Yeah, we like to think so.
I mean, in my introduction, I sort of highlighted 3 ways in which AI is really important for climate change, both understanding the impacts and perhaps the adaptation to climate change. But I think the 2 areas where Recycleye is working really is optimizing current systems, because you're quite often putting AI and robotics into existing sorting facilities. So you're optimizing what we already have. And obviously, it's a breakthrough green technology, and that sort of, one assumes, and we'll hear more, continues to innovate. So what is it that you're optimizing in the sort of recycling supply chain, and how does that work? And fire away. I'm not going to direct questions at you, so you can argue over my brilliant questions to answer them.
Yeah, so I'd say in a sorting centre, so once your waste gets collected from households, it goes to these big sorting centres. And a lot of the machinery is technology that's been around for years and years, heavy analog machinery. So that'll sort it out into different streams, be that aluminium cans, different types of plastics, cardboard, paper, glass. Obviously, every machine is only efficient to a certain level. Where we come in is really that final cleanup step, which is traditionally done by manual pickers, which isn't a fun job. It's pretty smelly if you've never been to a waste plant. So we're just trying to replace the manual labour and automate that final cleanup phase.
And is a robot as good as is AI and a robot as good as a human? I mean, humans are quite intuitive. They can sort of see 3D. They might recognize that it's a water bottle, even though from its label or its brand. I mean, are we getting to the point where, I know AI is very good at winning games of Go and chess and various things, but are we actually in flying drones? But can they deal with something as ignored but as complex as a mixed sort of randomly sort of presented stream of waste on a conveyor belt?
Yes and no is the real answer. So in our systems, I think our system is so powerful because it's a combination of AI with a physical system, right? The robot. And they communicate with each other. So the AI will tell the robot, go and pick this can here, this plastic bottle there. That's how the system works. So together with being so powerful, there's obviously limitations to both. So there's limitations to the AI and there's limitations to the robotic arm. So one thing that humans can do, for example, that a robot currently cannot do, and this is the current state, is, for example, humans can drag multiple pieces of waste in one go and kind of slow down the process. Because imagine you have this waste moving on a conveyor belt at constant speed, right? But sometimes you get more waste than others. Maybe in a minute you get a big batch. And what a human can do, it can just put his forearm on the belt and just drag it all further downstream and take his time to pick things. Yeah, kind of scoop it up. Obviously, the robot can't do that, right? So one of our prerequisites is that the waste is spaced out on a reasonable level. So having said that, a robot works 24/7, doesn't need breaks, is a lot sturdier in a way, right? Doesn't need to take sick leave or anything. So, there's all of the advantages of automation there that we've seen in other industries as well, in other fields. In terms of the AI, it's a very powerful system, but there's limitations there as well. So what might happen, doesn't necessarily happen, but what might happen is that if a brand comes out with a completely new label that is a different color and just looks completely different, or a completely different material, for example, and someone could go to the manual picker and say, oh, by the way, this brand's changed material, or this brand's changed color, but it's the same one, so sorted in a specific way. And humans have this innate ability to just pick up these kinds of inputs really quickly and just, it's not a problem, right? They'll just sort things out separately. Now, sometimes the AI will have this ability as well, but more often than not, it will need retraining. So it will need someone, an engineer, going in and saying, by the way, this piece of data that you've had so far, you need to sort this differently, you need to classify it differently. We've had an example in real life of a famous brand that makes really small white bottles. They used to be made of PET plastic. And all of a sudden, they decided they wanted to have them made in HDPE plastic, but it looks identical, basically. So we needed to retrain our systems to say, okay, when you see this small HDPE bottle, it's HDPE, it's not PET anymore. So yeah, I guess flexibility is something that humans have.
And I guess where's the Recycleye AI learning from? Because, rather famously when DeepMind's Go came on the scene and it won, maybe it was called something else, but it won Go, didn't it? Anyway, the DeepMind AI machine, when it won the world champion at Go.
AlphaGo,
thank you. It had spent hours or probably minutes, seconds, whatever, looking at thousands of videos of previous games, and that's what it was learning from. But I doubt there is that much video of waste. There's plenty of cats on the internet, but probably not that. I might be wrong, but there's probably not that much sort of footage of waste and people having a sort of an analysis of waste. So have you had to build your own data set to teach the machines, and are they learning while they're sorting? Because, does someone at the end of the day go through the stuff that they've sorted incorrectly and then tell the machine that you need to do it like this next time?
Yes and no. So we've had to gather our own data set. As you say, there's no images of waste on the internet, or none that are relevant to us anyway. So I guess maybe taking a step back, the way our system works is that we install what we call a vision system over a conveyor belt with the waste moving along. And what this vision system is comprised of is a camera and a computing unit, where the camera is much like what you have on your phone. It's just recording 24/7, and the compute unit is basically like a really small laptop. And what we do is we just record 24/7, and then later on get these recordings. We pick the most useful ones. So for example, we don't care about the recordings where the plant was shot, right? And there's nothing there. So we pick the useful recordings, and then we send those images to be labeled by a third party. And what this labeling process actually means is that there is a person that sees an image of waste and says, okay, there's a piece of plastic bottle in the top left corner and a can in the bottom right corner, for example, and labels every single individual object in that image. And we do this process for hundreds of thousands of images. And that's how over time we've built our kind of main data set. And then when we make a model, we have a training stage. And this training stage essentially means that we show our model these labeled images over and over again until it's learned itself to say, oh, okay, this is a plastic bottle or this is an aluminium can. And then we put this model on the small laptop, so to speak, that we have in the vision system and have the model do its detections.
First Mile is the UK's leading waste management service. We help over 30,000 businesses reduce their carbon impact with our award-winning range of recycling solutions. Go to our website, which is thefirstmile.co.uk, to get started today. If you're enjoying this episode, don't forget to subscribe. We have brand new episodes every Wednesday. Why do we need it? Because it sounds like, and maybe, question for Zoe here, that what's the customer? Obviously, people do need it because they're buying them, but the customer problem here we're trying to solve, it's we're not building entire recycling centers full of robots, not yet. So what's the optimization that we're doing at the moment? Is it simply we're just taking out a horrible job that a human does and putting a robot in, or is there some other uplift we're getting?
Yeah, I'd say that is definitely the main part. I mean, it's not just replacing people. The people don't exist for the most part. I'd say the majority of waste plants we speak to, especially in the UK, I'd say also true across Europe, but yeah, particularly here, there just aren't people that want to do these jobs. And when there are, the average person stays in the role for 6 months. It's very expensive to train people to recognise different types of waste. I mean, to Benny's point earlier about that drinks brand changing the packaging from PET to HDPE, they're not differences that people intrinsically know. It's something that needs to be taught and trained. It is a specific job. So sort of removing that labour headache, both in managing people and the hiring and resourcing, is a key part of it. And then just the quality control in terms of consistency throughout a shift. I think Benny touched on the fact that, people need a toilet break or a cigarette break and might get hungry and drop in productivity. A robot's going to perform consistently across the entirety of the shift. So that's sort of one key element. And then the other side of it is really the data that it provides. So in the UK at the moment, there's sorting requirements that are 0.05% of a waste stream, which is sort of legal regulations. At the moment, this isn't allowed to be automated. Hopefully that's going to be changed. But, that's a very small sample size to say this is what your output stream is, and therefore for a plant to understand how much value they're getting. At the end of the day, they're businesses. What is sorted by a waste plant is the value to that business. So it's really crucial for our clients to understand what their waste streams are and know what the output is. The fact that the robots are positioned at the very end of the plant means that the data that's provided is sort of directly translated into what they can then sell on. If they see massive fluctuations in, say, for example, we're putting it in an aluminium line, and you see a massive fluctuation in a certain type of contaminant, let's say PET bottles, then we know that maybe something has potentially gone wrong earlier in the stream, or maybe there's changing fluctuation in terms of what the overall input is into the plant. Does that mean you need to adapt anything else in the rest of the plant? Yeah, the value of data, really.
And do you think robotic sorting is going to come so good, and AI is going to be so good, we actually just give up recycling as we think we're doing recycling, which is sorting material at home, and we just chuck it all together, and then we get all these sort of armies of robots who are going to do an amazing job of sorting it? I mean, could the AI distinguish if we just send a whole pile of rubbish, Benny, do you think? And I mean, I think, Zoe, certainly the people I know in the UK waste industry would love the idea of it, but and lots of our customers, but I'm not sure whether the AI would ever be good enough, let alone whether the robots could sort of swim through mixed, sort of terrible looking waste. What do you think?
I think in the future it could be possible, insofar as I don't think that the AI would be the limitation here. I think it would be probably a lot less efficient. So the humans, as much as they're not great at recycling, frankly, they still help a little bit. If you all of a sudden put everything together, you're kind of taking a step back. And sure, you could just have more robots and more AI system deployed to help with that. But you are still kind of taking a step back in the chain. But as far as the AI goes, I don't see why it wouldn't work, potentially. I don't know if Zoe has other commercial insights on this, though.
Commercially speaking, I think the biggest change we're seeing isn't necessarily in sort of how it's collected domestically, although there are coming into place some new regulations around having more consistent collections across the UK, which I think will be beneficial in terms of future planning of waste plants. Not in the sense that it means that households just chuck everything into one bin and let the sorting centre deal with it, but more in terms of planning for the future. At the moment, every single plant I've been to looks different. There's some sort of difference in setup, and that'll be in part down to how they wanted it built and in part down to how they're receiving the waste. In the short run, changing to make this more consistent will be very challenging because those plants are all operational and running, and that big, heavy analog machinery is difficult to change. Whereas the beauty of AI is that it's adaptable. Benny and the team can sort of reprogram a model based on that changing waste stream, and our robot can be reprogrammed to pick something else entirely. You can't do that with the more traditional machines. That being said, I think in the long run, it will be beneficial to have a bit more consistency in collections across the country. But yeah, not necessarily in having everything in one bin, because that does pose challenges in itself.
I suppose, Zoe, when do you think we're going to first see a fully non-humans, fully automated, AI, robot-only recycling facility in the world? I'm not even going to say the UK. And Benny, what do you think is the key barrier to getting it?
In terms of fully automated facilities, I mean, first of all, I think we need to clarify when you say no manpower, we mean in terms of the actual sorting. You're still going to need someone to go and check if a machine's not working and perform the maintenance and whatnot. So fully without humans is never possible. But a facility that, in theory, if everything's running smoothly, runs by itself, fully automated, does already exist. I believe, there's a number in Germany. So yeah, it's definitely the future. And I think with new plants that are being designed, certainly all of the newer facilities that I've been to are much more reliant on the AI and the automated sorting machines than the analog machinery. So the shift is already happening.
Yeah. Okay. Interesting. Okay. Well, that slightly makes my question to you, Benny, redundant, because you could say, well, there is no barriers, but there must be barriers to wide scale adoption. Then what do you think they might be?
I guess the majority of the issues come from the flexibility of the system. So waste plants at the moment with their analog machines, those analog machines basically are set up to detect a certain type of material specifically, whereas the AI has the flexibility of detecting any kind of material that you want. So you could technically move AI systems across a facility. Having said that, every time a new material comes through, or if the plant wants to detect some new object, or if the legislation changes and some materials need to be sorted separately, the AI needs to be retrained fundamentally, and that takes time. So the AI is in a way more flexible because you can make it do whatever you want in a way. On the other hand, it will need retraining and it will take time to do that. So that's one barrier. The other one is, I think that a lot of the plants that exist at the moment in Europe are very much built around the analog machines that exist. Our robots are retrofittable, which means that you basically just fit them in whatever space these facilities have available. But often that's just not much space. And if you want to substitute the existing analog machines for robots, you're going to need to make quite a few changes to the plant in terms of, for example, how fast the belt moves or how wide a belt is and stuff. You can imagine, if a belt is really, really wide, then the robot is going to have to move a lot in order to move material around. So all of these are factors that impact the performance of the robot, but also how much throughput a plant will have. So all of this needs to be balanced out. And then I think another one limitation that comes to mind that maybe people don't talk about enough is internet access. Obviously, a lot of the plants need internet to get this stuff to work, and sometimes it's hard. Or maybe there is a bit of internet, but you don't get your super fast fiber, and so that can cause some issues.
On this show, we're building a Hall of Fame for climate heroes, and we always ask our wonderful guests to leave something in First Mile's Climate Heroes Hall of Fame. So, what or who would it be?
So, I guess I thought of Jan LeCun, who is kind of considered the father of neural networks, but most importantly, he kind of invented the technique, the way in which neural networks look at images, and they're able to recognize stuff in images. And that kind of basic technique is at the root of what we do at Recycleye, and what allows the Recycleye AI to see stuff in the real world. But really, on a much bigger scale, just any AI that sees, any AI that is based on cameras that does work, for example, to look at how much pesticide you're using on crops, or to pick up only the ripest fruits and let the other ones be. He is the father of all of those techniques, really. So I think he goes in my Hall of Fame.
Fantastic. Zoe, Climate Heroes Hall of Fame.
Maybe a bit of a cliche one, but Sir David Attenborough.
And why do you like him so much? Why would he go in?
I think the hold he has over people and the fact that he can share his knowledge so widespread and is so well respected means that he really gets to people and makes a lot of people think, which I think is really the first step, is not just making people aware, but making people care about the issues.
We have a couple of regular features on the show, and we'd like to get recommendations from our guests. So what's the best book ever written on climate change? Could be a TV program, TED Talk, film, Netflix. What's your recommendation for us to all go out and learn from?
Well, I think there's a lot of often conflicting opinions out there on what you should and shouldn't do. And for me, a book that I really like that I think anyone should read just on small changes that you can make as an individual, that's sort of broken down into different sections of household tasks, for example, and very digestible, easy to read, is a book called Is It Really Green? Just, is it more sustainable to wash up or use a dishwasher, for example? Little questions like that, by Georgina Wilson Powell.
Perfect. And she's been a past guest on the show talking about the book. So look at that. It's almost like we planned. It's almost like we planned it. Well done. Again, turning to the future here, we've sort of talked a lot about optimizing waste sorting, the importance of sorting waste and the importance of recycling. Absolutely. But are we using AI in waste recycling to focus enough on circular economies, waste elimination, reuse systems, or maybe unknown future techs at the moment? And have you got a division at Recycleye where you're looking at sort of, we always at First Mile say, look, we're a pipe end technology. Ultimately, a recycling company will be extinct at some point in the future. And that's the same for what you're developing now. And are you looking at what the world looks like in 10, 15, 20 years' time and moving more towards a proper circular economy rather than a recycling circular economy?
It's a good question. I mean, I think the whole basis of working in the circular economy is the fact that reuse comes first, right? That being said, with how our technology's been developed, it's very much being used for a very specific purpose, that being the sorting of the waste. There are a lot of companies, I think in particular startups, in the AI and waste industry, and a lot of them are sort of addressing very small and individual problems within that. So yeah, I know there are other companies that are doing this, and sort of combined effort means that there is AI systems in place that can sort of look at many different aspects of it. But for the time being, we're remaining quite focused in what we do.
And so I suppose moving away from Recycleye specifically then, I mean, will AI help us eliminate waste? Because that's what we're trying to do ultimately with the circular economy.
Yeah, I mean, I think AI in general will help, is definitely going to be a massive part of the picture. I think before eliminating waste, we just want to become really, really good at like reusing what we have. Currently, we are just producing so much stuff all the time. I mean, I can't remember the stats off the top of my head, but the amount of things that, and plastic specifically, that we produce on a daily basis is just ridiculous. So if we can slow down the rhythms of production by reusing more stuff and, just recycling what we have, then that would really help in the bigger picture. AI in general, I think, is the step forward in a lot of fields. Is just kind of the natural development of technology, and in the same way in which technology got us where we are now, hopefully it will take us to a kind of better place in terms of doing good by the planet.
I think to add to that, part of it is really around the narrative as to what is waste. I think in a lot of people's heads, plastic is evil, right? But in reality, I mean, depends on the polymer type and how many times that chain can be effectively recycled. I think HDPE plastic is a really good example. So your milk bottles, they can be recycled time and time again, reprocessed even. Time and time again, the average shelf life is 2 weeks. That's a very efficient system. Compare that to, say, cartons, oat milk, and maybe alternative milks come into. The only way that can be recycled is by downcycling it. You cannot make a new carton out of an old carton due to the multi-layer material. So really thinking about what materials we're using single materials as packaging. Back to the example that Benny gave earlier of that company that used to use PET and then switched to HDPE. Part of that was also removing a film that was wrapped around it, a sleeve, which they now no longer have. All of their information is printed directly into the HDPE bottle, which is great. It's minimizing different materials, it makes it easier to recycle, and therefore less waste is actually created and things can be recycled over and over again. So I think that's really key, and making sure that people understand the entire process really of what recycling actually means and what materials are best for that, because I think ones that are sometimes seen as being, oh, well, that's not plastics, that's got to be more environmentally friendly, is not necessarily the case.
And do you think final question really, do you think we're closer? I mean, my problem is not so much sorting as getting drivers to drive the dust carts and the bin lorries and recycling vehicles to collect material from businesses. Are we actually getting any closer with automated vehicles in your opinions, or do you think that's getting further away?
Yeah, no, for sure. I think automated vehicles are going to be here a lot sooner than people might think. Whether those automated vehicles will be destined to waste collection is to be seen, I think. But yeah, For sure. I think so.
Excellent. It's been fantastic having you both on the show, Zoe and Benny, for Recycleye. Thank you so much for coming on First Miles Climate Heroes.
Thank you for having us.
Thanks a lot for having us.
Thank you.
I'm Bruce Bratley, and you've been listening to First Miles Climate Heroes, where we meet incredible people making an impact to tackle climate change. If you've enjoyed this episode, leave us a review and subscribe to the show. We have brand new episodes every Wednesday.